In the world technology, there are many structures of building. The most important structure is the bit. Bit is one that affects to daily life. They are using the static touch structure theorem for creating the most efficiency bit to carry the load. The bit is project. The project is the bit.
สวัสดีครั
สวัสดีค่ะ
บ Hello everyone. Today I would like to present about our trust static project. First of all, I want to introduce member of our group. Start with me. My name is Gongpop Dilamian.
My name is Nalini Busha.
and me, Subhakit Saheng, and we have the other member of the group.
My name is นัทนพลเพิ่มพูนโภคากุล
My name is วลินทร์นันทราทิพย์
My name is Supanita Sisawang. Next, let's start our presentation with the objective and design. First of all, we were expected to build a truss that can carry up to 1 kilogram and has a maximum strength to weight ratio. This means that we have to build a truss with a less weight. The truss would be pin supported at 4 positions. The length between pins is 100 millimeters and the loaded would be 320 millimeters from the support. We are also requested to build a truss with wooden stick, 3 mm bolts and nuts, and other materials are not allowed. To build a truss, first we have to search for some important information. Here is what we got. There are 4 major types of truss: hound truss, pad truss, W truss, and Warren truss, and each truss has its own form with different benefits. In order to build a lightweight truss, we choose Warren truss to be the model of our truss. Warren truss is a truss that has triangle along of its length. Each force on the members of it gonna have equal force. The benefit of it is it has less member and less joints than other truss. So we're gonna use the benefit of this truss to construct our truss.
Now it's time to analyze the maximum carrier of the truss structure. The condition is the wooden stick must have a force up to tension and compression force. That's the reason why we must calculate the truss structure carefully. We use the point method to analyze the force in the truss structure in each member. First, we select point K. First, we select point K. As in the picture, we use the first Newton's law. The equilibrium conditions are using in point method calculation process. After the calculating process, we found that the force average in each member is around 60 Newton, and member AB has the most compression force 100 Newton, and the safety factor is around 2.
I will tell you about equipment that we are going to design truss structure. 1. Wooden stick. We use them as main structure and the size of the wooden stick in the picture. And 2. Bolt and nut. We use them for fix each of joint and we use 22 pieces for truss structure. And 3. Cutting machine. We use them for cut wooden stick get in shape. And the last one, drill pressing. We use it to hold on the wooden stick for bolt and nut. After that, we bring all parts of structure together and finally we will get complete truss structure. And the next, my friend will tell you about how to build truss structure.
Now we are going to present how to build the truss structure.
First step, we will select high quality wooden stick. The good wooden stick must have conditions such as no fracture in the wooden stick and no bend. After selection process, we will measure the wooden stick. Second step, we will drill hole diameter 3 by drill press machine because the drill press machine has less drilling force and precise in drilling process.
Next step, trim the dullest part of wooden stick for reduce the weight. After the trimming process is the final step, the assembly process. We will assemble wooden stick together by nut and bolt. The final truss structure will be like this. In this process, you must be drilling slowly and precise.
After that, we have to test the efficiency of the truss structure. My friend will tell you how to test the truss structure. Let's go!
After we finish design process and build prototype structure, now we have to make the first performance test to prove that our truss structure can carry weight followed by our design. Now, let's start the first test. Follow this step. First, we install our truss structure into the support and locking by the nut for 4 position. Then, we input the weight at the end of the truss structure, start with the mass 0.25 kg and hold in the 30 seconds, and then increase to 0.5, 0.25 and up to 1 kg. After we finish first test, the result of prototype model is the prototype model can carry weight 1 kg. Now we have to make the final model. For the final model, we try to reduce the member because we want to make the lightweight truss structure as much as we can. After we finish make the final model, we have to test again. The test is the same as the first test. Finally, we get the result of the final model test. The final model result is can carry weight 1 kg and the weight of the truss structure is 82.5 grams. That's all of the parts of the testing. Now let's move to the last part of the video.
To sum up, we use the Warren-Tuss theorem to build our bridge. We use the 24 pieces of wooden stick and 22 pieces of bolt to create the bridge.
And the final result of our truss structure, the weight of our truss structure is 82.5 grams. And our truss structure can carry weight 1 kg. The performance of our truss structure is 12.12. And this is the end of our truss structure presentation. See you next project. Bye bye.